Welcome to Bold Talk series where creativity, leadership, ideas, innovation come together. My name is Epi Ludvik, and today I have a privilege to have a short one-on-one conversation with Kevin Smith, Chief Engineer at Orbit Fab, where he leads the development of breakthrough technologies enabling satellite refueling and sustainable in-space economy. Kevin, great seeing you. Welcome to our Bold Talk series. How are you?
Doing great. Looking forward to our discussion today.
Awesome, man. Looking forward to as well. Space. I always get fascinated by space. But let's go back to your journey. What first sparked your curiosity about space and engineering, and how did that curiosity turn into a career?
Yeah, I guess I'll point to, I think it was about fifth grade. We had our rocket, build a little Estes rocket class in elementary school, putting that all together, kind of learning like fins and engines and like how do you deploy a parachute in that little package, going off, shooting it off, recovering it, being able to fire it a bunch of times. That's like, wow, this is really cool. So then that eventually became in high school, what are you going to do? I was good at math and science. I liked rockets. So mechanical engineering felt like a no brainer, and space. So that's what got me into engineering. And then I ended up doing a bunch of stuff with sustainable energy that seemed like kind of a cool area. I did a bunch there. I learned a lot of really good basics that helped me bring a different perspective to the space industry. So about 10 years ago, I joined an aerospace company that did aviation oxygen systems. And then I went on to Moog, which does a bunch of valves, engines, actuators for all kinds of space vehicles. And then I went to Astrobotic and worked on a lunar lander. And I've been here at Orbit Fab for the last 2 years, helping to enable an in-space economy, really driven by the ability to refuel spacecraft.
Amazing. That's pretty bold, man. Now, before Orbit Fab, you worked across different mission domains. What was one experience that really shaped the kind of engineer you are today?
I'll point to my previous employer, Astrobotic. When I joined, I was basically told Peregrine is done, which is the first lander that left, and you have a bunch of stuff we need you to help with on Griffin. My background with space valves, spacecraft usually fail one of two ways. Either the electronics or something screws up with a valve in space. So unsurprisingly, as we really started to get into integration of Peregrine, I got calls every day, it seems like, of things we had to kind of like fix. Peregrine flew on the first Vulcan Cert 1. ULA has had a very high interest in making sure that rocket went off as soon as possible. So working under conditions where you have the CEO of the company that you're going to write on saying, we will leave without you if you're not ready, really drives the team to understand, what do we actually have to do? What do we have to get done? How do we think creatively? How do we break this problem down into like the simplest possible thing we can solve today, rather than taking 2 or 4 weeks to get to like a 100% solution? Let's get 80% of the way there. Ultimately, we were able to get that spacecraft together. We did beat ULA. On Cert 2, there was another spacecraft that didn't quite make it. So that was a very real threat for us. We got there. We launched, a valve broke, and that was a risk we took. We understood what it was, and we were kind of trading, do we launch or do we take, or just not launch and like spend another year on this? And right, everyone at that company is like, I want to get my stuff to space. Like, it may not work, but we'll learn a lot. And there was a signature plate. So my signature right now is actually at the bottom of the Pacific Ocean.
Yeah. Um, so you have one. It's one of the main products is RAFTI, your refueling interface, and it's becoming a standard across the space industry. What design principles helped it earn trust at that level?
I think a thing we always struggle with in space is KISS, keep it simple, stupid. How do we go back to first principles? How do we understand what we actually have to do? And RAFTI, the RAFTI we have right now is block 3. So we had a couple tries before we really started thinking of, what does our customer truly need? We had to build something, put it in front of them, tell them all the ways they hated it. So that really drove to like, oh, these are the things they actually care about. So can we make something simple, simpler, something that meets our customers' needs kind of universally if you're using a monopropellant, and just think of a way to make it in such a way that we can make it cost effectively, on a schedule, and get it to any customer that needs it in a reasonable time frame. Again, I'll point to the space propulsion field, the valves, kill programs. We can get you a RAFTI in 6 months. There's other new players coming online that are really aligned with that. Like, how do we get you something in 3 to 6 months versus kind of my previous employer, Moog, and a lot of those legacy companies are really stuck in, hey, we know better than you. We're going to give you what you want, and it's going to take a year and a half, and it's going to cost 5 times what you want. And there's no other players anymore. So you have to kind of live with it. So it's really great to see the environment, the space industry changing, kind of responding to the demands of new space. You see the government pushing that way. I proliferated, cheaper, faster. And we need to get things up to space as soon as possible. So that's kind of a lot of the design principles around RAFTI were how do we meet that need? How do we work in that economy to get folks something that meets their needs on schedules, reliably? So we're really seeing a lot of positive movement there, both kind of some of our commercial customers and seeing the government really drive, hey, need to have refueling. There's a systems engineering review board that's run by the Space Force. So they've approved two interfaces. One is RAFTI, the other is the Northrop solution. I can tell you, I'll get you a RAFTI in 6 months and it'll cost you 30 grand. Northrop, they're just going to say, talk to us later. So we are willing to work with the industry, and that kind of, I think, really helps. We'll work with anyone. Northrop solution is a solution for Northrop. So we kind of have those different design principles of something for everyone or something that specifically meets our needs. So I think that's really what is helping RAFTI kind of take off and become an industry standard.
Nice. So, so I assume you work with all different um, organization outside of US. I assume.
We do work with quite a few. So we are based here in Colorado. We got about like 50 folks. We also have another 15 folks based out of Harwell campus in the UK. So that's kind of our more European facing side, but we've shipped RAFTIs to Japan. We've shipped RAFTIs to Europe. We're shipping another version of RAFTI to India soon. So it is a pretty multi-continental development.
Nice. Now, so obviously, launching a hardware is one. It's hard, right? But launching a hardware in the space, that's really really hard. How do you think about engineering for reliability in an environment where you're not able to touch that hardware once it's launched?
I'll go back to my previous answer of KISS, keep it simple. Can you solve this problem with 10 parts versus 100 parts? If you can imagine, like, reliability is, well, this part is going to work 99.99% of the time. As you start adding up those small bits, things can become pretty unreliable, and you struggle to operate in concert. So continuing to drive the team to, like, what has to work, test the crap out of it on the ground, and what's the simplest test we can do to get the best data as soon as possible. So I think I run an engineering department now. As an engineer, I want to spend all day in a science experiment. At previous roles, I've been able to do that, which is fun. You get to learn everything about something. But I think the true nature of an engineer is versus a scientist is I'm going to get to 80% of a problem. I'll do a curve fit and we'll send it. A scientist really wants that fully derived solution, understanding every single thing that could go wrong. And then it's just keep it as
Yeah.
simple as possible, test the crap out of it as early as possible. And that's how you really drive to a simple, robust, reliable
Yeah.
solution.
Now, obviously, it's I build different businesses and startups, but all the business that I built was something that was done before. In your case, you're building something that's never done before. How do you keep your teams focused and motivated?
Luckily, this has been done once before by DARPA on one of those $500 million missions. So they put a bunch of stuff to help ground us of like what worked, what didn't. Obviously, our solution looks a little bit different from that, but right, that's kind of the thrill of an engineer. Of there's a lot of merchant bus suppliers now. Of I'm going to make the same thing someone else makes. There's a bunch of them, and that is cool. You're going to get stuff to space, but you're kind of solving a problem that's been solved. So it's kind of an inherent motivation of any engineer to solve a really cool, unique problem. This week, two Chinese satellites, SJ-21 and SJ-25, looking like they're going to connect and demonstrate refueling. So that's also highly motivating to my team. Of China is demonstrating this technology. We have our solution. We're building it right now. We're launching it next year. So how do we keep America kind of at the forefront of space technology? I think the Space Force, ARL, a lot of the government entities see the absolute need for that. So that's also an external motivation. If everyone's like, we really want you to succeed, when you hear that from your customer and like what we're doing is super important, it's very unique. It really drives kind of external and internal motivation, which is kind of any engineer's dream of this is desired and we're going to do it.
Yeah. Now, what excites you most about how in space refueling will unlock I'm sure new industries like manufacturing or tourism or even mining in orbit. What truly excites you?
So it changed my background. A lot of what I did is sustainable engineering, sustainable energy. So the sustainability push just resonates with me.
Mm.
And there's a professor from the University of Buffalo. I'm from Buffalo. Actually had his brother as a professor at my undergrad. He said in space kind of servicers, it doesn't make sense because he was only viewing it from the perspective of I send a spacecraft up, it's going to grab something, they're just both going to burn up, which that makes zero economic sense. But when you add refueling into that, that's kind of where his understanding ended. I love kind of that perspective of like, yeah, there's a lot of smart people saying a lot of these things don't exist. But then once they hear about refueling, they really change their minds of like, well, if you amortize the cost of that over multiple missions, then the economics start to make sense. So how does refueling kind of support that in-space economy? And the biggest one we see are all the servicers, the clear spaces, the astroscales, Cal Morris, Starfish, there's a bunch of others out there. So refueling to them is intrinsic to their business model because they have to amortize the cost of that spacecraft that's going to deorbit a bunch of stuff over a bunch of missions. If you run out of fuel, you run out of movement, you end up back in the atmosphere. So that's LEO, and same in GEO is just enabling movement. How do we act there more sustainably? How do we get to a bunch of different transfer orbits? A lot of what we do is just we got to move like a Prius. We can't move like a Ferrari because we're going to run out of gas. So allowing the Ferraris kind of to get out there and start running around, we're really excited to kind of support that and see kind of what that enables, right? We feel like we're in some sense like an iPhone, but we don't know what apps are going to get built. So we're going to build the iPhone, we're going to have refueling, and then folks are going to do some really cool stuff we can't even like comprehend right now.
Now, how do you define what it means to take a bold risk? I mean, you're in a domain where failure is not just expensive, but it's mission ending.
I tell my team is a thing I believe, and kind of my example from Astrobotic is the only thing worse than failing in space is not getting there in the first place. So bold risks, I'd say there's a spectrum. I think on ground, if you're like doing anything else, it's a different spectrum than when you're in space of I'm not going to put up something I think will explode. We work with things that are inherently explosive, so 1%. So having a team be comfortable with like, we need to make decisions. We need to like meet our launch schedule. They're not always going to feel like super amazing about it, but like, hey, can we get to the pad? Are we going to be safe? No one's going to get hurt. And then the worst that's going to happen is we have a spacecraft that didn't complete its mission on orbit. That's kind of where the team drives to bold risks. Being safe is paramount. And in space, we work with some pretty raunchy substances. Hydrazine is really bad for you. So we have to be careful about that. But kind of on the spectrum, I think our team's pretty lined of taking the
Amazing.
bold risks, pushing the envelope.
Yeah. Yeah. Nothing without a great, bold team, right? This is truly inspiring and great work, Kevin. This is a short format conversation. We'll love to carry on another great conversation, maybe a long format. I like to ask this last question to my guests about what does the word bold mean to you?
Bold means kind of stepping out front, doing things other folks aren't comfortable with, either because they don't believe in themselves or they think it's impossible. There are things that are impossible. There are things that other folks won't do. If someone won't take that risk and to explore the boundaries, like the envelope will never get pushed. We'll never do anything super cool. We're going to stagnate. So supporting that, of course, like not being crazy, saying, hey, I'm going to vent warp drive tomorrow, but making steps like refueling in space, that might get us one step closer to that in the future. Kind of lining up reasonableness of getting something cool done versus something that's just so insane no one's going to believe you. I think that's bold versus delusional. So we try to be bold here and try to keep the delusion to a minimum.
Yeah, keep it realistic, right? Kevin, it's great having you here. Thank you for joining this short format bold talk series. Truly looking forward to seeing you next time. Until then, be great and be bold always.
Sounds great. It's been great talking
Take
to you,
care.
Epi. Thank you.
Bye bye.
You too.